Hi, my name is Tibi. I'm part of Sensorica Open Value Network, and I'm working on this photovoltaic cell characterization project. And in this very short video, I would like to introduce you to some aspects of the mechanical design. So just to get you up to speed about how this project is advancing on the mechanical side. I will share my screen and jump straight into the subject. So this is the working document that we use for the electromechanical design. We're gathering ideas. This is a more exploratory and horizontal work. You can see a bit here about the workflow if you want to participate in this project. At this particular stage, join the forum. You have the URL here. I'm going to put it in the link below the video. This is the working doc, and then content from here, it's going to get more structured and better formatted, and it's going to go into the main design and prototyping document, and eventually it will end up in a report, which will happen by the end of this week. So this milestone 1, it will end by the end of this week. So what are we trying to build here? Essentially, what we're trying to do is to build a gimbal that can rotate 360 in one direction and 90-degree in the other direction. This gimbal will hold a sample. This represents an axis of rotation here. And the sample that sits on top of this gimbal faces a lamp that mimics solar light that is placed at a certain distance. And the idea is to change the orientation of the sample and measure the transmission of light that comes from the lamp, goes through the sample, measure the transition of the light through this material as we are changing its orientation. Another way to see it, this is the entire experimental system that we will use. So essentially you have the gimbal that has 2 axes of rotation. You have a sample holder, and then you have the sample sitting on top. Behind the sample, you have some sort of device that collects light for data acquisition. This is the lamp that shines light on the sample, and the gimbal is controlled through an Arduino board, and everything is controlled and synchronized on a computer that runs Linux. We're not going to go into the software considerations for now, and we're not going to go into the electronics. We're just going to talk about the mechanics of this gimbal and in relation with the lamp and the acquisition device. So first of all, what is a gimbal? I have a GIF image here that we'll see. I'm scrolling down this document. If you want to join this project, actually this is the document that you should look into. Just to give you an idea about what is a gimbal. Actually, I have a better picture somewhere. There you go. So this is just a representation of a gimbal. It's not the actual thing that we want to build, but it shows you the functionality, right? So you would have a sample holder with a sample and some sort of actuators, okay, to change the orientation of the sample. The lamp would be sitting in front of this sample holder somewhere. And the data acquisition device would be sitting in the back of the sample. Again, the sample is a thin sheet of photovoltaic material that is translucent, and the idea here is to collect the light that it's transmitted through it and map whatever the signal we get with the orientation of the sample. So that's the basic idea of the gimbal. Now, this whole mechanical assembly has a few components. So I'm scrolling down here to see the components. There's the gimbal, which is used to orient the sample. The sample is sitting on a sample holder. There's a sample holder. There is a sample holder interface and a sample holder gimbal interface, meaning that the sample holder has to receive the sample, and you need some sort of clamping mechanism or something else, Okay, now we're just at the conceptual level. So here's the sample holder represented here. And this is the sample with its center of rotation. This is how the sample holder would rotate. And you need some sort of mechanism or interface between the sample and the holder to fix the sample in place. And we want to make this generic because this device can be used with other types of samples. So the idea is to have a sample holder that is a component of the whole system. So you can take out this sample holder and replace it with a different type of sample holder to receive other kinds of samples. And the main idea represented in this picture with red is that the samples should be fixed on the sample holder with some sort of mechanism. One idea would be a clamp. Now, one requirement of this device is to be very low cost and 3D printable. So since the sample position within the holder is very critical, it has to be aligned with the axis of motion. The design has some constraints. Okay, so as we design this holder to place the sample on it and these clamps, we need to make sure that there is some flexibility. If the 3D printed part is a little bit crooked, there has to be some set screw in order to put it straight in place. Now, the sample holder has to be mounted on the gimbal. So here we talk about an interface between the sample holder and the gimbal. So this interface here is represented in this image with the red arrow again, which is a fixture between the sample holder and the gimbal itself. So the gimbal rotates the sample along the vertical axis and also tilts the sample according to this point of rotation here. And so this sample holder, which is a part that has to be custom made for different types of samples, we have to be able to take it out and replace it on the gimbal. So it needs some locking mechanism here, a clamp or something else. Again, this is a very critical part because the way we put the sample holder on the gimbal can determine the position of the sample. It has to be aligned with the axis. So since this part has also to be 3D printable, there are some precision constraints. Okay, so we have to make the design a bit flexible so that if there is any error in the 3D printing of the part, we can always readjust it during the assembly. The next important component here is to have a fixture for the data collection behind the sample. So here you have the sample holder sitting on a gimbal and the lamp illuminating the sample, and then you have a data collection. Essentially, it's an optical fiber or some mirrors and perhaps some lenses that sit behind the sample to collect light and to bring it to the data acquisition device, which can be a spectrometer, photodiode, or other light detection mechanisms. And the idea is that we have to align this data collector here with the center of the gimbal. So if the sample holder is changes in orientation due to the gimbal, this data collector should be aligned with the center of rotation of this sample. There's a few ideas about how to make that. This is just a brainstorm. One idea is to have a cylinder with a base, which can be positioned on the table in XY and clamped on the table. This is a cylinder, so there's another tube inside or another metal rod that can be adjusted in Z with a set screw. And then it's terminated by a ball, and you have a platform sitting on top of the ball that can be rotated in all directions. So this will adjust the angle, this will adjust the Z, and this will adjust the XY. This is just an idea, but it can be something else. So let's go back to our list of components. which, sorry for the delay. So we saw the gimbal. We saw the sample holder, which is an independent part that can be custom made for a specific sample. It has to attach and detach from the gimbal. So we need a sample holder interface and a sample holder gimbal interface. The sample holder gimbal interface fixes the sample holder to the gimbal, and the sample holder interface fixes the sample to the holder. You have the data acquisition device that has to be mounted on the same platform and has to have some adjustments in X, Y, Z, and some rotations in order to align the data collector, which can be an optical fiber or a series of lens and mirrors to collect the light, and that has to be aligned with the center of rotation of the sample. And then you have a casing that goes on top of everything in order to shield the entire system from ambient light, and everything sits on a base, which is essentially a flat bed on which we can screw the gimbal, the data acquisition device holder, the lamp, and maybe the casing could be mounted on the same base. There you go. So this is a very rapid explanation of the main concepts of this mechanical design. If you would like to contribute to the project, just go to the project page. You will find a link under the video. And also you'll find a link to this main document. If you have any idea, please go on the forum, contact the team working on this project, and you're welcome to contribute. Thank you very much.